Hello, everybody. My name is Jodi Forlizzi. I'm the Herbert A. Simon Professor in the HCI Institute in the School of Computer Science at Carnegie Mellon University. And today I am giving a reprieve of my ACM SIGCHI talk, A Lifetime of Design Research in Human-Computer Interaction. I want to thank SIGCHI for this wonderful honor and say that in many ways, this kind of talk is really hard to give because you don't have a lot of time and you have to ask yourself questions, including, how do you describe a lifetime of research achievement? What has my career meant? And where is the field going? So I'm really excited to share my thoughts about the formulation and growth of design research in HCI, and there's a lot of ground to cover. So therefore, I'm going to give a broad and superficial talk, which will be a little bit biographical because design is a human activity that we all possess in our experienced life. And it's a little nostalgic because in the recounting of my lifetime of research, certain experiences remain formative. And I'll draw out a couple of themes from my research, which I feel provide evidence of the importance of and broadening application of design research. And then I'll provide some conjecture on the future of the field. So all of my research is collaborative, and the process of doing collaborative interdisciplinary research is a joy. It's truly what keeps me going every day. And there are too many colleagues to list. But I especially want to thank my current and former PhD students and postdocs, and my faculty members and collaborators at CMU and beyond. Together, we change the field of HCI. So I'm a first-generation college student, and I went to University of the Arts in Philadelphia, where I studied illustration. And after undergrad, I worked at University of Pennsylvania doing technical illustrations in an engineering and science building. And that was a formative time because today I collaborate with scientists all the time. Fast forward to today, and I'm a design researcher who has studied educational games, interaction with robots, interaction with agents, interaction with AI, and the migration of things that were once physical to the digital realm, and how AI and automation change work practices. Harold Nelson talks about accidental vagrants, which are animals that thrive in contexts where they have not traditionally been. For example, land birds at sea. All kinds of animals can become accidental vagrants. They serve as creative and innovative solutions for positive change within the ecosystem. And so it is with me, as a scholar of service and systems design, working within human AI interaction. And my mission is to ensure improvement of the world through the technologies that we design and develop. So early on in my career, the notion of design research in HCI was fairly non-existent. So the first era of my work on design research was actually as a master's student at CMU, investigating user experience in interaction design. At that time, most people understood design research as the work that is done at the beginning of the product development process, or as iterations on a particular design, such as a visual communication, to help the designer understand what the best solution might be. At the time, traditional design skills were of little help in understanding how people were making sense of user interfaces and what led to errors, for instance. There was also a big gap between what designers envisioned and what design tools could do. There was a lot of handcraft and hand prototyping. I remember, for example, crafting kinetic typography movies painfully frame by frame. Some design researchers at the time created concepts that explored emotions, user experience, joy, fun, and pleasure. And the work on this slide was from Kees Overbecke's lab, and it explored if a vending machine could offer stern or friendly interaction. Design research that took the form of speculations on the future, such as Bill Gaver's drift table, appeared in Chi 2004 as an extended abstract, but these were few and far in between. So I was a master's student at CMU at the time, and the role of the UX designer was emerging. UX designers served as the advocate for the user in all aspects of product development. At the same time, technology was moving off the desktop and into consumer products like phones and VCRs. This suggested that designers look at the interactions around the product, which were as important as the product itself. And at that time, we expanded these concepts into a framework for user experience design based on pragmatism and in particular, John Dewey's book, Art as Experience. The model describes 3 types of user-product interactions. Fluent user-product interactions are the most automatic and well-learned cues. Cognitive user-product interactions focus on the product at hand and can result in knowledge or confusion and error. Expressive user-product interactions are interactions that help the user form a relationship to a product or some aspect of it. And these unfold in a particular context, yielding 3 types of experience. The first experience is the constant stream of self-talk and self-assessment of what is going on. An experience is more coalesced, something that could be articulated or named and has a beginning or an end, often inspiring emotional and behavioral changes in the experiencer. Co-experience takes place as experiences are created together or shared with others. People find certain experiences worth sharing and lift them up to each other. This work gave budding design researchers a flexible way of studying individual action in social, technological, and institutional contexts. And it used the notion of experience as a way to connect research to user experience research in industry. And by stating that all experiences are inherently social, it predicted a near future of alternative experiences in social media, VR and AR, and AI. As early as the late 90s, the CHI community began to see more examples of design research. For example, the Maypole project was a 2-year EU research project that spanned a number of universities. And the goal of this project was to develop communication concepts for children aged 8 to 12 and their social networks. This project was a great design project. It had multi-phase design projects, including user studies, participatory design, and other forward-thinking design activities. The team made a working photo taking and sharing system and allowed kids to play with it. And this helped to demonstrate and even foreshadow MMS services and camera phones, which are now ubiquitous. It's a great example of design research that shows how researchers can use design process of making things as an approach to generating new knowledge. Meanwhile, at CMU, I was part of a group of researchers who started to formalize design research in HCI. And through a series of workshops and interviews, we formalized an approach called research through design, a way to conduct scholarly research that employs the methods, practices, and processes of design practice with the intention of generating new knowledge. It framed design inquiry as a distinctly separate activity from engineering inquiry and scientific inquiry. And in research through design, design researchers understand the current state, then suggest an improved future state in the design of a thing. We classified 3 types, which describe 3 intellectual traditions in design research at the world at that time: lab, field, and showroom. So in this model, design researchers following an RTD approach work to integrate 3 types of knowledge in the design of new things. From engineers, designer researchers take how knowledge in the form of technological capabilities. From behavioral scientists, they take true knowledge, models and theories of human behavior. And from anthropologists, they take real knowledge, thick descriptions of how the world currently works. Based on these inputs, design researchers then ideate and prototype many possible visions of the right thing, a preferred future state, by imagining new products, services, systems, and environments that address problematic situations in the world. The work in our lab typically involved understanding behavioral and social norms around technology that did not yet exist. And we generated many kinds of design artifacts, for example, technical opportunities such as Johnny Lee's Calder Toolkit, gaps in current behavioral theory, such as how a robot should hand an item to a person, new prototypes in situations of study, and many different kinds of design artifacts. We also sought to produce knowledge, and this is quite different than design research conducted with the goal of making a commercially successful product. This was for a pragmatic reason. We needed to get tenure at a computer science school. And our 2007 paper on this framework, after going on and off the accept board at CHI, which back in the day was a physical board with physical Post-it notes, was finally accepted for presentation at CHI 2007. And today there are 2 design subcommittees at CHI, which are huge, and there are whole conferences dedicated to design research in HCI. So researcher design continues to expand across the world in rich, extraordinary ways, and so it did in the research in my lab. In many of these cases, we used researcher design to investigate a design space that was inordinately large, too complex to examine instance by instance, and where no social norms existed around the technology that we were designing with. For example, CMU first became interested in human-robot interaction around the year 2000. There was an interest in how robotic technology could assist elders and caregivers. And this picture shows CMU's NurseBot and Nurse Robot interacting with residents at a local retirement community. This was a visionary project at CMU and an opportunity for principled study, but the function of the design of the robot was conceived of by technologists. So there was actually little understanding of how elders would actually use this technology, and there was no holistic approach to the design and development of the system, nor an understanding of the social context of use. In addition, the robot was expensive and fragile, and our lab was invited to help repair the robot's cracked head. Instead of simply fabricating a new head, our group took this on as a research project. We gathered a collection of robot heads, coding them for important dimensions such as head height and width and the presence or absence of features. Older and younger people rated the robots, and we performed statistical analyses to show designers what people cared about. And we identified 2 important dimensions that drastically affect how human-like people perceive a robot to be. The first is the length and width of the head. This affects how young, old, machine-like, human-like, and even intelligent the robot is. And the second is the presence and absence of certain features like eyes and lips that create a locus of interaction. We designed a new head, which you see here on the right-hand side, and we used it as a basis for further study of how people respond to assistive robots. And this was the first paper published on human-robot interaction at the DIS conference. Our lab's work on design research and human-robot interaction continued to expand. For example, we did an ethnographic study of elders and caregivers in their home, studying how product use changed as elders faced physical, cognitive, and social and emotional decline. We identified over 50 opportunities for how robotic technology could aid these stakeholders and grouped them into 5 opportunity areas. This work also led to a theoretical framing about product use, the product ecology. It offers a systemic, ecological view to depict interactions with products among multiple stakeholders in environments and social spaces. So this moved design research beyond a UX framing to a service design conception in our work, which looks at multiple stakeholders and considers value to be a design material. We examined some of the opportunity areas from the elder ethnography, generating prototypes and studying them in real-world environments. We built the Hug, a telepresent articulated pillow, which had some working technology, and the Sense Chair, a chair with sensors in the seat, back, and arms to detect deviations from behavior and to send reminders or assistance as needed. And in this work, we built technology as much as needed to demonstrate and evaluate aspects of our research. We also built SnackBot, a social robot that provided a useful snack service to the community. This robot was a focus of study for nearly 6 years. We varied aspects of the design and behavior to better understand how people will interact with robots over the long term. We study the effects of these different design features and of different service strategies. And we did this by looking at the robot as a product service ecology rather than simply a product, and by using lightweight prototyping to understand responses to the robot and its interaction designs in social settings. We explored theories of human behavior, in particular anthropomorphism, behavioral economics, and cultural models to help shape the design space of human-robot interaction. In one of my favorite studies, we looked at some of these advanced theories of human-robot interaction to see if they differed from human-to-human interaction. This study used cultural models, relational, utilitarian, and oppositional, as a framing mechanism to understand how social robots should recover from error. It turns out that apology is the most effective and increases how much people like the robot and their willingness to interact with the service it provides again in the future. We also explored similarities and differences between human-robot interaction and human-agent interaction, and a near future where an agent embodiment might move through different instantiations, some physical and some virtual. We studied and designed robots in a number of settings, ranging from offices to homes to factories, hospitals, and face-to-face service settings and hospitality settings. This work explored how agents could be integrated along with robots in collaborative settings, exploring themes like trust, affiliation, and re-embodiment and co-embodiment. At the same time, our lab also became interested in a growing number of devices that track personal data about oneself and others, and the perceived value of this data, which people continue to collect even if they never interacted with it. We developed this stage-based model of personal informatics to suggest ideal ways to prepare for, collect, and make use of this data, noting how changes in goals and context can affect people's perception and interaction with the data. We also studied virtual possessions, things like money, photos, and traces of online social interaction, some which were once physical but now exceedingly digital. This was an excellent space for design research, and we built what we call user enactments, settings with demonstrations of the technology where study participants could immerse themselves in a scenario, experience sips of the future, and provide input on the future they desired with this technology. For example, this completed space for a user enactment shows a teen bedroom. We asked pairs of participants who were friends to come to the bedroom, hang out, read homework together, and then we ran the user enactments. For this study, we learned that small details matter to help suspend belief, but other times the settings for exploring social interaction around technology can be quite simple. This work led to findings about the value in placeless, spaceless, and timeless virtual possessions for teens, and to understanding about how differences in virtual possessions are used by different cultures and different generations. Research through design as a method of investigation was applied, iterated on, and formalized through methods, exemplars, and academic research products. It continued to spread through the community. There are too many examples to enumerate in this short time, but I hope you can see that the boundaries of research through design continues to expand as it's used in more and more complex, problematic situations. And so some of our current work, preparing hospitality workers for AI and automation in the workplace, is by far the most expansive use of research through design in my career. Labor industry experts predict that technology has the potential to automate more tasks in the hospitality industry than any other industry. Large numbers of hospitality workers are being displaced by these technological changes. During the pandemic, it was estimated that nearly 90% of hospitality workers faced unemployment, and unemployment rates continue to be high due to a shift in contact-free services. So our research team is examining this change and studying interventions and actions to help workers, employers, and technology to be successful across this change. Today, in the hospitality industry, robots meet, greet, clean, assist in surveillance, transport, and deliver products and services. So meet Flippy, Chippy, Sally, and Sippy, robots that make food, deliver it to tables, and clear tables. But robots are only a small part of the technologies used in the hospitality industry. In addition to robots, AI, VR and AR, IoT, smart rooms and smart sensors, big data and little data, biometrics and facial recognition, and conversational UIs are used. These systems are used to track demand, reservations, volume, pricing, inventory, guests, and employees. And technology is transforming the customer experience, the definition of service, the numbers and types of jobs, but most fundamentally, the experience of workers in terms of tasks, workflow, work volume, and skill requirements. Many are hastily considered designs, and there's even less consideration for the implementation, rollout, training, and impact to workers. So for the past 3 years, our work has been looking to create opportunities for workers to envision, design, and engage in worker-oriented research and training around the future of automation in hospitality. We're working with 4 collaborating universities and Unite Here, the largest hospitality union in the US, to ensure that worker satisfaction, voice, safety, ownership, and agency go hand in hand with an understanding of future technology and future work. Hospitality is invisible work. It is a physically demanding job done largely by women who are immigrants and women of color. And as employers move from daily housekeeping, because in many hotels you don't get housekeeping every day anymore, the work of housekeeping is becoming harder. This is because during a checkout, the housekeeper does a deep clean of the room, changing sheets and towels, scrubbing the bathroom, and this can take a couple of hours. In a stayover, the work is as simple as emptying the trash, making the bed, and maybe just picking up a little bit. In many hotels, housekeepers are assigned to sections every day. They clean the same floor or wing or set of rooms. And the assignment of rooms was traditionally done with paper. And so the term of art for the list of rooms is called one's board. But digitalizing hospitality deprives housekeepers of the autonomy of doing the rooms in the order that they desire. With an algorithmic manager to assign rooms, revenue is optimized, resulting in many checkout rooms in a row. And this can be exhausting. There's little consideration of the safety and health of the worker. The algorithm managers tell housekeepers which room to do next based on an algorithm, so workers can't always see their whole board, and it requires some technology literacy, which they are probably not trained for. And also the board can change over the course of the day, but there are some advantages because these algorithmic managers enable faster communication between housekeepers and other operations such as managers or engineers. Now, the social science literature on automation has traditionally focused on job displacement, for example, as seen in manufacturing with robots. But the recent literature highlights complexity, especially in the service sector. There's some specific skills in this work which are challenging to automate, and work processes and job content are changing. And it's not a simple one-to-one mapping, such as replacing tasks with automation. Technology is truly transforming the experience of work, and the context of the organization plays a role. And in the hospitality industry, it's even more complex because hotels can be branded, owned, and managed by 3 different entities. And this can affect whether basic, minimal, low-road implementation takes place, or if change managers are utilized to manage high-road, robust implementation of technology. So I want to touch on a few ways that design research is at play in this work, and these include principles from service design and research through design practices that ensures that we are working to design the right thing. Through workshops, observations, interviews, and co-design, we are using research through design to envision how automation and algorithmic managers might be better designed, developed, trained, and deployed with the input of workers. So talking to guest room attendants or housekeepers gave an individual perspective. Talking to managers gave an organizational perspective. Talking to the manufacturer of the software revealed additional conflicting perspectives. And talking to hotel management revealed yet additional perspectives. Research through design can be used to look at these holistically. And we can often see in this work that there's a prevailing notion that technology isn't bad. But in many cases, in looking between these stakeholders, we see that simple errors and misuses come from misunderstandings, uneven training, inconsistent configuration of the software. And all of these problems can be examined ecologically using the lens of design research. We also do a lot of work to reframe from this notion that tech is bad. And here the design method of reframing, or getting to the assumption beyond the assumption, is useful. For example, we could compare Amazon delivery workers and UPS delivery workers who are both monitored in their jobs. They do the same jobs, but they're treated quite differently. UPS workers are viewed as valuable points in a data collection mechanism who improve the algorithmic systems with their work. But on the other hand, Amazon drivers are managed by algorithms and viewed as expendable commodities. And you may have even heard stories of Amazon delivery workers being fired by an algorithm. So in this reframing, we see on the one hand, delivery workers who are commodities, and on the other hand, delivery workers who are empowered and able to inform how data and algorithmic managers might be used. And data collected about UPS drivers is reviewed by humans and not algorithms. And if UPS drivers are fired or they need to escalate, they will have a human manager with whom to interact. So we continue to do prototypes and other types of user enactments to help hospitality stakeholders imagine an ideal future, along with the social and cultural norms that might surround it. So the prototype on this slide emerged as a way for housekeepers to order their room assignments. Through workshops and interviews, we began to understand how algorithmic managers impact daily work. And then our research team collaborated with workers to sketch new designs. What we found was this notion of self-sequencing, or the ability to order rooms, would increase their self-efficacy and their sense of transparency. And it would also reduce their workload because they could have the ability to order rooms, checkouts, and stayovers as needed. The current workaround is to mark all the rooms in progress in the algorithmic manager and then go about their day. And this idea of self-sequencing led to members of one culinary local, Las Vegas 226, to gather issues and report to union stewards and ask for the ability to self-sequence rooms. So one of the outputs of this research design was actually language in their contract around the ability to self-sequence. And this work has garnered the attention of policymakers who realize that innovation and technology development are strategic imperatives for our country's economic and national security. And so, inspired by this work, the CHIPS and Science Act established a technology strategy with guidance from NSF. And it sort of talks about how it's important for universities, industry, government, and labor organizations to work together in these problems. And I recently had the benefit of testifying to Senators Schumer, Round, Heinrichs, and Young in a closed-door briefing on AI innovation. And I called for recommendations based on our research to bring workers into the design, development, and training and deployment processes of these technologies, to design sustainable AI from the very beginning of the product development process, and to make digital and AI literacy training programs readily available for all workers. And these ideas fed into some of the language in the president's executive order late last year on trustworthy AI. So now to the future. What will the impact of research through design be as an ongoing research mechanism? As evidenced in the community, and hopefully by my talk, research through design continues to change and become richer and be applied to broader, more complex sets of problems. However, I worry about the trajectory of the peer-reviewed design research in our community. I want to collectively invite us as a community to prioritize ethical, purposeful, pragmatic, and rigorous research that withstands the test of time. There is a difference between societal problems and trendy topics, and I hope as a community we can recognize that. I also want to persuade the research through design and CHI communities to re-examine what has become a very heavy submission and review process. I think we will do best design research when we allow for risky, imperfect, nimble, novel contributions that allow us to innately research and design the world around us in a direct and straightforward way. Thank you for the opportunity to share my thoughts today. I hope you can go forward and continue to do productive, useful design research. Thanks again.